Lesson 56, data types. We will learn about the difference between different data types. And there are we're going to talk about 4 different data types, and we're going to sort of talk about how do we sort of break them up into their different regions. We'll probably, yeah, so let's talk about, firstly, 56, by the way, the fact is barium. Barium is a metal in the periodic table. It's periodic table element 56. Some facts about barium. Barium is actually considered, has some really heavy elements to it. Like barium makes some heavy, not elements, but some heavy compounds. It's actually one of the only things that's really, barium sulfate is really, really good at blocking X-rays. So if you ever need to go have an X-ray and they're like, all right, well, we're going to test your digestive system. You're like, well, your digestive system has no bones in it. So what they might make you do is they might make you drink this barium sulfate sludge, white mixture stuff, and that will go through your body. I don't know, I haven't been told if it tastes good or not, but I imagine it probably doesn't taste good. It goes through your body, and then when you get an X-ray, it actually will show up on the X-ray. And it shows up on the X-ray because it's so then it's really good for someone that's like, okay, well, we want to look at what's going on in someone's digestive system. You can look at using X-ray to see that. The main other reason, of course, that barium's here is because it's one of the symbols in the Breaking Bad sign. And when I originally made this, and believe me, I made this a long time ago, 5 years ago, Breaking Bad was like, oh my God. I have to admit, Breaking Bad's such a good show. It wasn't, and if you haven't watched it, suggest that you watch it. It is intense, like, you know, it is like, you know, you can't just like walk in there and be like, it's going to be sunshine and rainbows. You better strap yourself in, but it is gripping. I watched all of it. Then my wife watched it and she's like, oh my God, and we would start to watch it together. We watched the last season together. I think it was really, really quite good. And also depressing, and the symbology as well was really interesting. But yeah, I've got some friends that have started to watch it too now, and they're like, oh my God, I didn't realize how good this show was. So yeah, I would suggest that. And of course, a lot of people would draw attention to the fact that I was a chemistry student that became a teacher. And so when it was, I was like, hey, Miss Greer, are you going to break bad? I'm like, listen, I know the chemical makeup of methamphetamines, and sure, I could probably carry out the reactions necessary to get it to work because I've studied recrystallization and stuff like that. But you know, probably not going to do it because believe it or not, making methamphetamine is not the hard part. It's the selling it and not getting like shot or arrested. That's the difficult part. Anyway, data types. Lesson 56. Where does this come from? This is coming from our new topic, which is univariate data. And that's coming from our overall grand final idea topic, which is statistics. Ladies and gents, our very last 2 topics are going to be statistics. Now, statistics are really, the older I get them and the more I look at statistics, the more I appreciate them as being something unique with mathematics. Statistics in so many ways are, believe it or not, the most political type of maths. Ultimately, statistics can mean, when you first think of maths, you think of maths as being a bastion of truth, you know, someone that tells you the way things are. There's no objectiveness, there's no politics. It's just, you know, if it's a right angle triangle, then the angle is 9 degrees. You know, there's no ifs or buts. There's no, oh, it's only 90 degrees if you look from this perspective, it's 90 degrees. But statistics is so interesting because when maths gets political, in my opinion, statistics is just so interesting because it's like someone that's really good at maths can make statistics do what they want. And therefore they can make it look like certain situations are favorable and not favorable. And it's so murky and so interesting. And so therefore there are so many bad statistics out there that are just really, people pointing out things that are wrong, and it's just really and there's like one of the ones that I watched recently, all the statistics got to do with back in the 50s with regard to health and smoking, and how there were so many people saying, yes, smoking causes lung cancer, it's really bad, but a lot of people that were saying, no, smoking's fine. Let's manipulate these statistics to prove that smoking is actually not hazardous. And it's like, oh my God, the more I looked at it, the more I was like, it was just crazy. Like, and but it is, it is very interesting. And so that's why, even though I do love pure mathematics and stuff like that and graphing, I find statistics very interesting. It's also it's got a lot of coding in it. If you're someone that likes coding, if you can code, then you can probably do statistics a lot better. And there's a lot of, it can get very, very complicated, even though at the basic levels this is very simple. And I've never really gone into it, but it's definitely a part of maths that I would be interested in. Out of probably all maths, probably one of my weakest parts is statistics, even though like at the base level it's pretty simple. But let's get started. The first type of statistic we're going to do, the first of the two last topics we're going to look at, is univariate data. Now the univariate data has this word uni, meaning one, and variate meaning variable. So we're looking at one variable data. You might say to yourself, okay, one variable data, that's going to be boring. Like, what's one variable? You just go, well, like, let's just choose a random variable. The classic, let's just go with height. Okay, what? Okay, so you go with height. My height is whatever, 1.8 meters, done. Well, 1.7 meters, whatever it is. I don't care. That's it. That's one variable, done. There we go, finished. Let's do a test. But the power of this is, yes, sure, we're only measuring one variable, but we are measuring one variable for a lot of different people. 1.6 meters, 1.65 meters, 1.85 meters, 1.82 meters, 1.79 meters. And what we want to do is we want to say, if I get a bunch of different variables, how can I analyze this? How can I break that down into something that makes sense? How can I start to understand that list of numbers? And that's what our job is going to be. Yeah, there are lots of different ways that we can plot. We can do it. We can use a stem and leaf plot. We can use charts. We can use lists. We can start to find the mean, the median, the mode, the range. We can find something called an interquartile range. We can find how far away certain numbers are from the median. Is this a very broad list or is this a very small list? There is so much information that we can get from just one variable. And understanding one variable is going to be our starting point. At the end, the second topic, the one that we're going to be doing in term 4, is we're going to look at bivariate data. And bivariate data, if you haven't already guessed, is two variables. We're only going to stick to one at the moment, but we're going to talk about two variables later on. How does someone's height affect their weight? How does someone's age affect their height? How does someone's annual income, how is that related to the distance that they travel to work? Is there a relationship? Is there no relationship at all? That's going to be things that we're going to explore. And all of these things are going to come together. But to do this, the first thing we need to do is we're not going to start with univariate. We're not going to start with one. We're not going to start with variable. We're going to start with just data. What does data mean? And to do that, we're going to look at the data types. So we're going to start off with the two overarching data types, and I'd like you to understand the two overarching data types are categorical data. Now, categorical data, we represent this using categories. Now, a category in this type of context usually just means a word, or I prefer a label. Whereas numerical data is the other type. It's like the contrast to this. Numerical data, we represent this using numerical or number values. And we're going to talk about what these mean in a bit more specificity in a little bit. But yeah, those are the basics. So if I ask you what type of color something is, that is going to be a category, because it's a color as a category. There are so many different categories, different sport actors, location, capitals around the world, countries around the world. What else can I say? Let's think of TV shows that you might like. That's a category. Any of these things are categories. Hair color category. Whereas down the bottom, numerical data, these is data represented by numbers. So when we talk about age, height, weight, the amount of money that a house makes, income someone earns per year, the house value, how much a house is worth, how many liters of petrol your car can take, how many volts of electricity you get for during when you're for house electricity prices. Guys, you can probably tell I'm running out of things here to talk about. But yeah, all of those are numerical pieces of information. Both of these are important when discussing numerical data. And you might think, oh well, categorical data, sure, we can make some nice pie charts and stuff. You know, what's your favorite ice cream, and then that's it for categorical data. But it can actually do a lot more with it. Just because you're breaking things into categories doesn't necessarily mean that you can't explore how many people are in that category and how does that relate to the total. And there are also some special types of categories which allow you to do a little bit more maths in. Let's talk about those actually. Let's talk about those. Let's talk about categorical data. So categorical data can be further split. So categorical data can be split into nominal data and ordinal data. So categorical is split into nominal and ordinal. Now, nominal data is like a collection of names. That's what the word nom means. It does not mean to eat lots of food. In this case, not like nom nom nom. In this case, it comes from the Latin word nom, or the French word nom, which means name. Nominal data is a collection of names. Which of the following colors do you like most? Blue, green, red, or yellow? These are nominal. These are names. Which suburb do you live in? Braybrook, Sunshine, Footscray. These are names. Which is the closest capital city? That's a name. Anything that can be attributed to having a name is considered to be nominal data, and that's how we talk about it. Ordinal is also based on names, but it has an order to them. Let me just check before I do this. Yeah, there is a bit of an example, but yeah, anything that has an order to them. So what's an example of some ordinal data? Well, let's take my favorite example, or the quickest example, is this. Days of the week. Now, these days of the week, don't get me wrong, do these days of the week are these nominal? Are these names? Yes, they are. But notice how I've written it down. Now, I could have written it down like this. If I said, what is your favorite day of the week? I could have written it down like this. Monday, I was going to do it in alphabetical order, but I kind of stuffed up. I could write down the days of the week like this. And, you know, I could say, which is your favorite day of the week? But there's something weird about that. That was actually really difficult for me to do, just to write that down. The reason something weird about that is because even though they are names, these names fall in a cycle. And so why it's important to do that is if you ask someone, what is their favorite day of the week, you would expect a lot of people to say Saturday, and then you'd also expect a fair few people to say Friday, and probably some to say Sunday. But and you would probably expect very few to say Monday, and you'd probably expect something like this as a graph. And that's because, and this is the power of ordinal data, is that the order it gives an understanding sort of well, what is going on. There is an order to this system. It's not just random. Now, you could also ask someone like this, you could say, well, when you could do a statistics, you could say, when are the most car accidents? When did the most car accidents occur? And so you could have like a graph that sort of shows when the most car accidents occur, and that because it's an ordinal set, you can sort of use the fact that you know how the days of the week work to get you a better understanding of what's going on. Are there other forms of ordinal sets? Yes, there are. Can anyone else tell me something that works in a cycle that's similar? Let's put this in chat. Something else that works in a cycle that would be similar to the days of the week. Month. Yeah, months are great. So if you have, you know, January, February, March, April, May, June, July, August, September, October, November, December. If you ask someone, okay, when do people take holidays the most often? You might see that like there is a big spike around January and February, but then there's a pretty big stuff, but then there's pretty much not many people taking holidays during the rest of the year. And so you could use that information. Now, if these were just randomly written down, if there was no order, then you wouldn't be able to sort of do that. Another one would be, well, we're going up, so we could talk about, instead of talking about months of the year, we could talk about seasons. Summer, autumn, winter, and then spring. We could, you know, look at, you know, how many flowers are there present during these months. We could look at what are the bee populations doing, how many bees are there. We could talk about how much wind occurs in different months. And so this could be another way you could do it. This is also order. Again, there is an order to the seasons. One last one that I always like to do for this is I always like to do this random order. This is another spicy. This is my Nando's scale. I don't eat a Nando's, guys. I don't really like Nando's very much. I think it's incredibly overpriced. I know some people are massive fanboys of Nando's. I'm like, you know what, I get it. But yeah, this is a scale from mild to extra hot. There are no measurements here. There's no measurement saying this is 20, this is 30, this is 40 milligrams of spice mix. It's just a word given to a different phrase. You could also do, by the way, small, medium, large, extra large, so on. Extra small, And so this could be t-shirt sizes, or it could be yogurt tub sizes. It doesn't matter. The point is that this is another ordinal scale. And it's another way to think about these kinds of things. Yeah, okay. So now I'm going to move on a little bit. Here's another classic ordinal scale though. This is one, I think I remember taking this, I think I snapped it, I think I stole this from somewhere, but you guys are really familiar with ordinal scales because you've done so many of these types of surveys in the past. And these are ordinal scales. Strongly disagree to strongly agree is a standard scale. I think this scale actually has a name, but I forget what it's called. I'm not that much of a statistics nerd, but the power of this can be is that you can still do maths on this. You could be like, oh, well, if you got all of these answers, you could call this a +2, a +1. And so then if you then added all the +1s together, added all the scores together, you could, you know, if you could find out if it was a particular quiz, you could find out how much someone liked the product. You could figure out how much someone is if you get like a score of more than 20, then you're a sociopath or something. Likert scale. Who's that? Thank you. Oh my God. Natalie, you're the best. Thank you. I'm pretty sure that's what it's called. But yeah, and that's a really good way that statisticians use to sort of evaluate how much someone believes. And so you could be like, you could do these scales and then use them to compare and stuff like that. There is some special software that you can use, but that's just another example of an ordinal scale. Strongly disagree to strongly agree. I want to give you guys a lot of examples, mostly so that if you ever get asked, give me an example. You guys, I've already gone through days of the week, months of the year, seasons, spice factor, t-shirt size, and then strongly agree to strongly disagree. I've given you 6 examples of ordinal scale in the past 5 minutes. So if you guys ever go, oh, I can't think of an ordinal scale, there's 6. So and there are more. Trust me, there are more. I want to talk, before I move on as well, there's one more thing that is a little bit of a gotcha kind of thing that teachers love to do. And it's this kind of, and I'm going to show you because I want to make sure that it's clear. And that's this. Can you ever use numbers in categorical data? And most people would say, no, of course not. No, of course you can't use numbers in categorical data because it's categorical. It should be just categories. But the answer is that's actually not right. The answer is yes, but not often. The category is postcode. So once you look at these, right? These is the number of students from each postcode. So we've got 3046, 3060, 3064, 3058, 3042, 3048. And these are different postcodes. Do you guys recognize any of these postcodes? Is any of these postcodes your postcode? Because I actually can't recognize any of them. It's been a while since, I think, 3048. No, I don't recognize it. I think I picked it from when I made this question back in the day. I think I picked postcodes near the school. But yeah, I guess not. That's fine. Maybe I didn't. Point is that these are postcodes. So even though, yes, it's a number, you can't actually do any maths on that number. You can't go, oh, well, if I have, you know, if I have 10 people living in 304, if I have, where is it again? If I have 10 people living in 3046, then that means that they're two worse than people living in 3048. So these ones are better than those ones. It's like, no, you can't do that because they're just postcodes. They don't actually have any numerical meaning. The other example for this is that we usually call is it's not as good, but it's like shoe sizes. So I'm a size 11. We've got size 10, size 9, size 8, size 7. Not to mention that women's size shoes are different. Adri, what shoe size are you? I'm asking him because, you know, male shoe sizes are the same. Have you got, no, he's got pretty big feet. 9 or 10, yeah, I thought so. We'll go 10 because, you know, big feet, you know what they say about big feet. They have big shoes, so yeah. Anyway, so we'll go 10, and then yeah, my parents call me Bigfoot. Yeah. Tim, you're here. Tim, what size shoe are you? Come on, you must be 11, right? Maybe you're 12. Come on, how big is your foot? Do you know? So remember, this is recorded. Yeah, I know. My sister is 12 and man's, wow, jeez. That's huge. Bigger than my foot. Anyway, the point is, the point that, Rochan, what about you? How big is yours? You can't just write big. Come on, you guys not know? Okay, we're going to move away 7 to 8. Okay, cool. All right, we'll go with 8. The point is, though, is that before we get into too deep, is that these shoe size is an ordinal data because it's kind of, we know that size 9 is bigger than size 8. We know that size 10 is bigger than size 9, and size 11 is bigger than size 10, but we don't know what it's measuring. Like 11 what? Size 11 shoes are 11 what? They're not 11 centimeters. They're not 11 inches. What are they? 11 whatever. We don't know. So that's what we're talking about here, is that they're not, even though they are numbers in this case, they're not linked to anything specific. And yeah, sure, you know what, there probably is some way that you could go, oh, technically the US shoe size is blah, 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 blah. So girls' clothing sizes are a trap. Yeah, well, you know, they all lies to you, I tell you. You know what's worse about sizes and stuff like that, in my personal opinion, Michelle, is that I can buy an extra large shirt at Tara Cash, and I walk and I put that shirt on and I feel it fits me perfectly and I feel good about myself. And then I go and I buy an extra large shirt from like YD or Connors and I put it on and it's small. And I'm like, but the extra large shirt fit me before, and then I feel bad about myself because I'm like, oh my God, I'm fat. I just need to get a double XL. But then I go back to Tara Cash and I put a double XL on, and it's like I'm wearing some kind of apron. It's so huge, and I'm like, like there's no standardization. So it's an XL here, and my wife has the same thing. She would get Princess. She would go and she'd go to Dangerfield, buy a Dangerfield dress for extra large. She'd get a size 16, and she'd be like, oh great, this fits me really well. Or she'd get a size 16 Princess Highway. Guess what? She ain't fitting in that anytime soon. And it's just like, why? It's the same size, and I don't know. I don't get it here. Anyway, I'm glad. Anyway, what's this? So it's the same size jeans, shorts. They're all the same. It's like there's, yeah. It's Andrew, you are right here. I'm going to tip my hat off to you for knowing more about fashion than probably your average 16, 17-year-old male. But yeah, it's also about style. Just because it's a size 16, it might be cut in such a way that it doesn't fit every person, and so on and so forth. But this is a maths class, not a fashion class. So let's keep moving. Numerical data. You guys can tell hopefully that I'm sort of more casual today. I just feel like having a chat. So hence why I'm not really super duper focused. Hoodies are the best, yeah. And you're right, yeah, tight fitting. You might want to get skinny jeans. Yeah, sure, they might be skinny, but they're skinny for a reason, so that they look cool, even though they might not fit as well, but they're still the same size and whatever. It doesn't matter. Numerical data is our next point. So we've talked about categorical data. Numerical data is split into two types. Numerical data is split into discrete and continuous. We're probably going to spend more time dealing with numerical data than any other type of data, but I think it was still important for us to talk about categorical data first. Continuous. Now, yeah, no, skinny jeans. I never liked skinny jeans, just for the record. I've never worn them. I will wear straight cut jeans. I used to like bootcut jeans, and then guess what? Bootcut jeans went out of fashion. Nobody liked them. I still like them. Anyway, numerical data is discrete or continuous. Let's talk about continuous data first. Continuous data is like one of the harder ones. Continuous data, and this is, I often get students get a little bit confused about continuous data. Continuous data is data that can be continued to be added to. This is because we can measure it more accurately. Now, a lot of people don't, I think whenever I ask people, then the question is like, oh, what is continuous data? They say, oh, continuous data, it just continues forever. That is not the case. Continuous data doesn't go on forever. Continuous data just means data that can be measured differently. And that's one of the key terms here, measured, okay? For example, I could ask you how tall you are. You could say you are 2 meters tall. Or you could say you're 1.7 meters tall. Or you could say you're 172 centimeters tall. Same measurement. Or you could say you're 1,724 millimeters tall. All of these are correct. They're all the same value. All they've done is they're measured to different levels of accuracy. They're measured differently, okay? Or you might say different levels of precision, because you're getting more and more precise. So, and then that's any type of data that you can measure more precisely is a type of continuous data. So for example, if I was to ask you, how tall you are, how far away from home you are, I could ask you how much you weigh, I could ask you how I could measure time. I could say, how long did this person take to run this distance? All of these are continuous variables because, yeah, sure, I can measure it with a ruler or with a stopwatch, but I could always measure it more accurately. That's what continuous data means. Continuous data, the continuous part means is you can continue to measure it more and more accurately. That's opposite when we deal with discrete data. Discrete data is one that has one value. Discrete data is data that has one value. How many goals did Hawthorn score? If Hawthorn was playing the game against North Melbourne and they scored, I don't know, we'll go with 12 goals. That's it. You can't measure more accurately than that. Rather than the other one where you can measure, you could measure one of the players' weight to within a milligram, you can't measure the amount of goals any more accurately than 12. The difference between continuous data and discrete data, in my opinion, is continuous data you measure, but discrete data you count. So that means 12 goals. If you ask how many children do people have? That's going to be, you're not going to be able to measure how many children someone has more accurately. If they have 2 children, they have 2 children, that's it. Money is also, believe it or not, is discrete. How much do you earn? And so whatever that is, let's say it's like, 48,000 per year, that's a discrete number. You can't measure that more accurately. You can't go 48,000.000. Once you know that number, you know that number. Another way that people kind of cheat, and this is not a good method to memorize this, by the way, is this. But it's not a good method, so why am I showing you? Because why not? Because continuous data is usually a decimal, whereas discrete data is usually just a number. That doesn't mean that that's always the case. Obviously, if someone weighs 27 kilos, if someone weighs like 87 kilos, that doesn't mean that you know, there must be discrete because it's not decimal. And just because the price of an orange is $3.52, oh, there's a decimal point, it must be continuous. No, because it's a money value. But it's just it's a quick little way that you can, if you look in the question and you really quickly have to answer it, it's got a decimal point, it's more likely that it's continuous data. It's not, but it's not a foolproof test. I would not be recommending this as a foolproof test. So those are the differences between continuous and who is 2 meters tall? I don't know anyone that's 2 meters. I mean, I'm sure there are people that are 2 meters tall, maybe somewhere in the world. I don't know. I wear tight fit. Oh, Andrew, I could not pull that off. My hand goes off to you. So those are the are there any questions about the difference between discrete and continuous? Again, the lesson here to understand. Oh, there's a question. Maybe it's not. Maybe it's just like the main difference is continuous is data that you measure. Okay, the main difference is you measure the data. So whereas discrete data is data that you count. Okay, continuous data, the reason that it's called continuous is because you can continue to measure it more accurately. Not because the number goes on and on and on forever, but because you can continue to measure it more accurately. Discrete data means that it fits into a box. 12 is a box. 13 is a box. 2 children is a box. You can't measure more and more accurately. One of the ways that we sometimes refer to it is a ruler. Continuous data is like a ruler. You can like zoom in and get a better and better and better answer. But discrete data is not like a ruler. It's just like if I have 4 balls, if I have, you know, the difference between is working out how long is this length versus how many balls are there. There are 4. It doesn't matter if I get a ruler out or if I get some special counting device, it's still going to be 4. But this one, I could measure that to be 1 centimeter or 11 millimeters, or maybe if I measured it really, really accurately, I could measure it to be 1,233 micrometers or something like that. But I digress. The point is the main one is continuous data, measured data. You measure it. Discrete data, you count it. Any other questions on this before I move on? 2 children in a box. Yeah, let's yeah, let's not clip that part of the audio, shall we? And move on. Okay, let's move on now to grabbing a look at, I guess, how we could look at these. All right, here we go. Ooh, here we go. Let's do some practice here. Which type of data is this? I enjoy studying, true or false? What do you guys think for this first one? For number 1, what type of data set do you think it's? Nominal, ordinal, continuous, or discrete? And if you really can't be bothered, you can just write down the first letter in chat. What do you guys think for this first one? What type of data is that question going to be? I enjoy studying maths. What do you guys think? Okay, I've got N and I've got D. Okay, I've got 2 Ds and I've got 1 N. Is there any other guesses on what type of data this is? I enjoy studying maths, true or false? Yeah, no, I'm not asking you, Roach. I'm asking you what type of data it is. Is it nominal data, ordinal data, continuous data, or discrete data? All right, let's give it a crack, shall we? Because I'm going to take the 3 answers that we've got here and we'll go with that. First things first. True or false? These are the possible answers that we could use. Are these numbers? Yes or no? No. So that means the answer has to be one of these two, because they're not numbers. Okay? If we had numbers or measurements, it would have to be one of those two. True or false? There's only two answers here, so therefore you haven't got enough to have an order. So therefore, this is nominal data. These are names. These are names to give different states. Now, you could maybe turn this into some kind of weird discrete data, but in this case, yeah, it's nominal data. Let's look at number 2 here. How many televisions do you have at home? What type of data is this going to measure? Nominal, ordinal, continuous, discrete. Bayu says discrete. Is there any other guesses? I want to get another guess here. Emily says ordinal, or is that just an O that you've forgotten to put an H at the end of? I can't tell. Who's got a different guess? Let's go with wait, D. Okay, D. Got 3 Ds. Any other? Can I get one more? What about yeah, Tim agrees. Okay, cool. So this would be it correct. Firstly, how many televisions? We're gonna give the answers would have to be a number, like 1, 2, whatever, maybe 0. I don't know, whatever it is, has to be a number. So therefore, it has to be. Well, it doesn't have to be, but it's likely to be one of these two. Continuous. Oh, whoopsies. Continuous or discrete. In this case, we have to choose. Can we measure this more accurately? Well, no, I can count how many televisions. I don't need a ruler. It doesn't matter how accurately I'm going to get it to the answer. This is going to be discrete. You can't measure it more accurately. You can't continue to measure it. Once you've counted one TV, you can't go, oh, there's 1.00 TVs. No, that's it. Once you've measured it, once you've counted it, you're done. Remember, discrete is about counting. Let's look at the third one. Oh, I keep tapping that. I apologize. 3. How do you like your burritos at Nando's? Mild, medium, hot, or very hot? I mean, I've already given you guys the answer to this, but you guys should be able to tell me really quickly, what type of data is that? How do you like your burritos at Nando's? What type of data is that? Is it discrete? Is it ordinal? Ordinal from Tim and Rochang, and what about like Janaea and Logan? What do you guys think? I haven't got any answers from you yet. Is Logan even on here? I assume she is. I can't. Yeah, she is. Yeah, ordinal. Okay, good. Thank you, guys. This is ordinal. Nice and easy. This is ordinal. Why? Because these are names. That's our first clue. These are names. These are not numbers. Second clue, these are in a ranking system. Because they're ranked from low to high or whatever, we know that therefore this must be ordinal. By the way, low to high is also another form of ordinal. You have a very low, low, medium, high. That's another ordinal. So there you've got 9 examples. Another one, by the way, is if you look at your grades on your report, you can get your grades on your report as either 80%, 90%, 50%, or you could get them as B, A, E probably. All of these, the ones at the top, those are discrete. And as math teachers, we really prefer giving you discrete numbers because then there's no guessing. Whereas the bottom one is ordinal data. And so, but parents love ordinal data. Whereas my problem with ordinal data is you can get 89% and get a B and be like, but you know, you can also get 81% and get a B. And it's like, well, one of the B's is better than the other B. And that's why, as a math teacher, I prefer discrete numbers to be put on your reports. But every other teacher at the school likes ordinal of the A, B, C, or the very high, medium, low, satisfactory, that kind of thing. So yeah, it's just another way that you can think about reports. So it's just, yeah, let's keep going. Number 4, what is your shoe size? What type of data is that? I've already done that one with you guys, but you guys should be able to tell me. This one is ordinal. I'm actually just going to skip that because you guys, we've already done that. What about this last one? 5. How long does it take to get to school? Can you guys tell me what type of data is that? How long does it take to get to school? Want some answers in chat? Who haven't I seen? I haven't seen continuous from Rochung. That's a good one. I haven't seen Eric giving any suggestions here. Discrete from Emily. So we've got 2 C's and a D. What about our good friend? What about I also haven't seen Michelle give. I don't think she's given an answer for this for a while. What do you think, Michelle? Do you think it's continuous, discrete? Do you think it's ordinal? Do you think it's nominal? What do you think? What even is just a letter? You've got a couple of answers you can borrow from. We'll wait for one more answer anyway. What do you guys think? Continuous, discrete, something? Oh, okay. All right. Never mind. I've got some relationships to repair. Michelle's not happy that I called her out. Okay, anyway. I do, but you're so funny when you get mad. I suppose I do bully you. I apologize, Michelle, for picking on you for accidentally picking the wrong answer. But I will continue. Can't even see me. I know. All right, let's work on this. So the next one, the last one is continuous. And the reason that it's continuous is because it's a measure. You're working how long. So the answer could be, you could measure this to be, 40 minutes, or you could measure this to be 42 minutes and 15 seconds. And you can continue to measure this more and more accurately. There is no limit to how accurate you can measure how long it takes you to get to school. So yeah, it's just a different way to look at it. And so therefore it's just a different thing. Now this last slide that I'm going to show you guys, so this next slide I'm going to show you guys is this here. Now this is a little, for me, what I sometimes use as a bit of a cheat sheet. So this cheat sheet here, we break up all of data into 2 major types, categorical and numerical. And I always think of these types as categorical as quality. These are the qualities something can have. So what something can be, and when I guess it takes me back to science. It's like quality in science is like what color is something. You could talk about, how reactive it is. You could talk about whether it has claws, whether it has fur, whether it has big eyes, whether it hunts at night. These are all qualities of something. Whereas numerical is about quantity. It's about numbers, how much of something you have. Quality can be split up into 2 groups. This nominal, which is a description. Does it have brown fur, black fur, whatever it is? Or ordinal, a ranking, and whether it's small, medium, large, or so on and so forth. Discrete is an exact value. It's an exact value that you measure, that you count. So 2 children, or you can't measure 2 children more accurately than that. You can count them 1, 2. That's it. That's as much as you can get. You can also see the problem as well when you try and measure discrete values continuously. If you say you had 1.56 children, you'd be like, that doesn't make sense. How do you have 0.56 of a child? Whereas you can only have 1 or 2 children or whatever. Continuous is a measured data, so it's some kind of measurement. It's like if I get a ruler or a stopwatch or a mass, or I get a precise voltmeter, whatever you want, the continuous value is something measured. So here are some examples on the left, on the right. Nominal data, and you don't have to write these down, sorry. I know I've got a big pencil here. I just want the big bits in purple written down. You don't need these extra bits on the right, but sometimes they might help. If you want to, nominal, quality. It's like the hair color, eye color, you know, whatever. It's the presence or absence of claws, or you know, your finger. I was about to say finger length. That would be wrong. It's not finger length at all. Ordinal, strongly agree, disagree, to disagree, how hot something is, small, medium, and large, extra large, so on and so forth. By the way, just for that side point to Adri, if you had like, what type of jeans do you like? Skinny jeans, straight jeans, you know, that would be stretchy jeans. That would be a nominal thing, because it would be like, you wouldn't, even though technically you probably could order them from like least to most painful to wear, you wouldn't actually do that in a proper thing. Anyway, discrete, count, tally how many of a certain type of thing there are. And then another way to do discrete is the number of students. Like, you know, how many students are there in a class? How many goals did someone hit? How many flowers are there on your walk to school? I don't care. It's some kind of value for an exact number that you can count. Whereas continuous is something that you can continue to measure. You can continue to get more accurate. So mass, so how many kilograms you weigh. Time, how long something is. Length, how long something is away. And weight, how much something weighs. So all of these are different ways that continuous, something can be measured continuously. I should mention as well, time doesn't have to be minutes and seconds. It could be days, it could be months. Mass could be kilograms. These things can be, length could be meters. It could also be kilometers. So you can have different sizes of these units too. But that's the main 4 types of ways we deal with. You know what? Yeah, know what? Yes. So those are the main 4 ways that we deal with data.